Alright, so today we're going to do lesson 7.2, which is talking about similar polygons. So this is the definition for similar polygons. They have the same shape, so triangle and triangle, but they're not necessarily the same size. So yesterday, like we were setting up proportions, similar polygons are when their proportions and their congruent and corresponding side lengths are proportional. So they have to have the same unit rate. So if we're looking at these two polygons, what kind of polygons are these? Quadrilaterals. So in order for these to be similar, they have to have these corresponding angles. So A is congruent to W. I know that based on the number of rainbows they have. If this has 1, that means that it is similar to W. So A is similar to W, B is similar to X, C has 3, so it's similar to Y, and D is similar to Z. So just like they have corresponding angles, they also have corresponding sides. So if I was to set this up, I would put AB over WX, just like this. Okay, and I would find BC and put it over XY. So AB's length in this case is 15, and the WX is 5. BC is 12, and XY is 4. What's CD? 21 over 7. And DA? Over. Do you notice that all of the top ones came from one polygon? So all the tops, all the numerators came from one polygon. All the denominators came from this one. So don't flip that up. Whichever one's on top stays on top. Whichever one's on bottom stays on bottom. Now, if we reduce all these down, what do they all become? 3 over 1. So these are similar polygons because they're all proportional. They all equal the same thing when you reduce them down. Okay, here's example number 1. If triangle ABC is congruent to RST, what does that tell us? What does this statement tell us about what to do to the triangles? Randy? You think you know? If A's first, what's it congruent to? R. So what is B congruent to? And C? Because it's saying, well, if these are congruent, so that's how we know which ones are equal to what. List all pairs of congruent angles and write a proportion that relates to the sides. So, I want to know what angle A is congruent to. We just did this, R. Angle B is congruent to angle S. And angle C is congruent to angle T. Now, if I wanted to write a proportion, there would be 3 setups. So, whatever one you put on top, the similar parts have to go the same on the other one, but on bottom. So, if I say that AB goes on top, Anna, what would go on bottom? Good. Okay, if I said BC, because I'm going from the same triangle, so AB's on top, BC's on top. So what would go on bottom of BC, Dustin? Good. And then last I have AC. RT, yep.
Does it matter if you put AC or CA?
No. Is that what you're going to ask? Doesn't matter.
So, you could put, instead of putting AB on the top, you could put RS and then just do it that way?
So if you put RS here, what would you have to put on bottom?
AB.
Yep.
Okay, and then do that for the rest of them?
Mm-hmm. So whatever way you stick with, whichever one you do it the first time, you just have to stick with it. So if you flop them, you need to flop them for the rest of the way. Okay, scale factor, the ratio of the lengths of the corresponding sides to two similar polygons. So this would be a scale factor of these two polygons. In order for them to be similar, they have to equal the same thing. They have to equal the same in order for these to be similar. For example, if you would have flopped them, so let's just say that I have a scale factor of triangle ABC to triangle XYZ is 6 over 3. What does that reduce to? 2. Okay, so that's my scale factor. I'm going to take the same two polygons and say I flip them. Well, then their scale factor is going to be 3 over 6, which reduces to 1 over 2. So this is flipping, so the second scenario is just flipping these. But it's the same thing. So as long as it's consistent, it is a similar polygon. Like if you would have flipped, if RS would have been on top and AB would have been on bottom. So Tan is designing a new menu for the restaurant where he works. Determine whether the size for the new menu is similar to the original menu. Okay, so this is kind of set up wrong. This is actually, these both are the same thing, and this is the original menu. This is the original menu. They're both the same thing. So I want to know, these are two different styles. So is the original menu going to be similar to this one? And is it going to be similar to this one? So these are two different problems. Well, let's write, using letters in the sides of these, a scale factor. So if I'm saying AB, what goes on bottom? FG. And it needs to be equal to this other side, so AD, which would be equal to FH. So not only, you could have written AD first, and it still would have worked the same way. So what is the dimensions of AB? 10 over FG is 12. That was in the original. So this is the original. This is the new. Oh, wait. No. This is the original. And this is the new. So 10 over 12. Don't let that confuse you because this is 12 as well. I got the denominator from this one. Okay, now 12 inches over 14. If I reduce these, will they equal the same thing? No. So are these two similar? No. If you don't really want to think about reducing these, just divide them. Well, 10 divided by 12 is 0.83, and 12 divided by 4 is 0.85. Not the same thing, not similar. Okay, let's do the second one. AB to RS, AD to RU. So I have 10 inches over 8 inches and 12 inches over 9.6. Okay? We don't want to think about it. 10 divided by 8 is 1.25. 12 divided by 9.6 is, so are they similar? Is their scale factor the same? Alright, now we're moving on to triangles. So, in number 1, we want to determine if they're similar, and if so, we need to write a similarity statement and the scale factor. This is a similarity statement. Okay, this is a similarity statement. When we divided this bottom piece, we got 1.25, right? That's our scale factor. Your scale factor is whatever these are when you reduce them. So let's try number 1. I always write a similarity statement first so I know which dimensions to put where. So they're saying that AB, and if you want to, you can go ahead and label the sides. I know this is supposed to be similar to this. Well, how do I know that? Because this angle right here is 59 and this one's 35. So they are correctly labeled on our paper. But for some instance, look at this one. Is C congruent to U? No. Sometimes they flip them. U goes with A. So be very careful in making sure you're labeling everything correctly. AB goes with DE. BC goes with EF. And AC goes with DF. Alright, let's plug it in. What's AB stand for? 6 over equals 9 over equals 10.5 over 7. Notice all the top ones came from the first triangle, all the bottom ones came from the second one. Okay. 6 divided by 4, 1.5. 9 divided by 6, 1.5. 10.5 divided by 7, 1.5. Are they similar? What's the scale factor? So you can shorten this by saying SF is equal to 1.5. Okay, so yes, this is a similarity statement, but I think what they're meaning is they want to know the triangle similarity statement. So triangle ABC is congruent to triangle DEF. So we got our similarity statement, we have our scale factor. Alright, let's go ahead and finish that. Okay, that was doing triangles. Now we're back to polygons in general. So let's find if these two polygons are similar. So you have to set up at least two sides. So I'm finding X and Y. Well, first of all, are these set up in the right order? R and A go together, S and B go together, T and C, U and D, V and E. So we can look at it correctly. Now, I need to find out what Y is. But I can't just put Y plus 1 and over 8. I have to have another set to go with it. So, is VU going to go over ED? Did I set that up correctly? Yes. So I'm just setting up the proportional parts. VU and ED go together. But I need to know two more parts that just have numbers. So I can't use this side because I can't have Y and X in the same statement. And I can't use this one because it goes with X. I can use RS and AB. So RS goes on top because that's the same one as VU over AB. Now let's plug in the numbers. So VU was Y plus 1. ED was 8. RS was 4. And AB is 6. Can you find Y from here? Cross multiply, yeah. 6, Y plus 1 equals 32. Okay, yeah. I got 4 1/3. Okay, you would find X using the same way. Use this same one right here because those both have your numbers already. And instead, just do X and 3.